Hi there, welcome to this session. So in this session I'm going to explain how to tune the SQL performance by using cluster index. In the previous video we have seen the basics things. What is index, what are the factors that affect the SQL performance. So those factors we have seen in our previous video. In case if you don't watch that video, please first watch that one. That is the basic that I have covered, and then in this video I'm going to start with cluster index. This is one of the main factor that will affect the performance while you're doing SQL query. So first we'll see what is cluster index, and then we'll get into the demo how to create cluster index, how it will affect, how it will improve that SQL query performance. Okay, I'll move on to the next slide. So here, before we get into that cluster index, we must know what is index. The main purpose of an index is to speed up the data retrieval. If you are passing any query from the to server, it has to respond very fast. So for that index will play a main role to speed up the data retrieval. Also, it has some additional things. It also reduces the number of database data pages. Normally in table we have multiple pages. Each page has no 8 KB in size. If the data is exceed that 8 KB, it will create a new page. Okay, that's how the table will be decided by the SQL. So if you are creating an index, means which will reduce the data pages visited. So that is the main purpose of creating index. Okay, normally there are main two factor of index we need to consider. One is cluster index and non-cluster index. uh, but usually there are many different types of cluster index which is available in SQL, but these two index which is very common, that play a big role in performance, in SQL performance, retrieving data from the server. So in this video we are going to see first what is cluster index, what are the what it's going to do, play a major role in in a SQL table. Okay, in the next slide I will explain what is cluster index. The cluster index, as I said, if you create a cluster index in a table, it determines the physical order of data in the table, which means it will change the physical order of data in the table. Suppose it will change the order of data if you create a index in the table. Also, you have to create only one cluster index per table, which means if you make it one order, can't reorder that one, right? That is where we need to create, that will allow only one cluster index per table. Also, the leaf node of a cluster index consists of data pages, which means actually that when you're creating the cluster index, it form a B tree structure. So from this structure, the leaf node, which all contains data pages. Maybe I will explain more detail about this the data pages in coming videos. And the next one is, also if you set the primary key for any column, it will create automatically in the cluster index for the column. So you no need to explicitly need to create the index. See, if it is a primary key, means by default the cluster index will be created in that column. On the next one is, it occupies own space, it's highly redundant, which means if you're creating any index, it will occupy more space. Also, it is redundant. It's not a mandatory that you always need to create a cluster index. It is optional. If you want to improve, suppose if you are seeing some bad performance letting the data from the table, you have to go for the cluster index. Otherwise, it is not a compulsory that you need to always create a cluster index in the table. Okay, I believe that you will understood what are the main factors that when it comes to cluster index. Okay, and then next one I will explain, as I said, right, if you create a cluster index, it will form a B tree structure. I will explain that structure of the B tree. Okay, assume this is the B tree structure. The If you're creating a cluster in a table, it will throughout the table it will arrange that order through pages, multiple pages. These are the multiple level when it comes to B tree structure. First one is the root level, and then this is intermediate level, and then third one is leaf level. So as I said, the leaf node cluster index consists of data pages, which means this area, this is a leaf node. This leaf node contains all the data values. Suppose this 1 to 50 kind of rows which is available in this leaf node, and then 1 to 25 which is available here, 26 to 50 which is available here. This is the common B-tree structure. When we are creating a cluster index, it will form this kind of an level in the table. Okay, now assume that this is on select query. Select column 1, column 2 from table A where column equal 24. Assume that uh, we have created a cluster index in column 1. So which means now that the table have formed this kind of an B-tree structure, the table. So when you are running this query, it will go first the root level. It will check whether the value is between 1 to 200. Yes, it is 1 to 200. And then check next condition whether it needs to go to left or right. Now in this case it needs to go to left. So the right is getting failure, so it go to the next. Again it will come here, again it will search one, it will be between 1 to 100. Yes, it is between 1 to 100. Which side it needs to go, left or right? Again it's left, just success, because in right side we have 50 to 100. So 1 to 50 it will come here, and then again it will go from 1 to 25 because it is column is between 24, right? So automatically, see, if we have only take only 3 pages, assume this is a 1 pages, this is 2 pages, this is 3 pages. But when it comes to third pages, it will got the data. This is how the B-tree structure will work when it comes to cluster index. So it won't go to all the pages for the searching this data. By easily within 3 steps we can get the data as we want. So as you can see, we have retrieved data with the less page number of pages. um, like assume that it's read only 3 pages, it won't do the whole table scan. With the no third the kind of 3 types of level, we get our output. Maybe I will show you one quick demo how to create a cluster index. After creating the cluster index, how it affects the no physical order of the data in the table. Okay, now I have created one database test, and then I'm going to create one table person. Here I have only 2 columns, one is ID and another one is name. See, if I don't create any index in this table, I'm going to insert some data from advanced database. So I'm just inserting some data into that table. Okay, now I'm going to select person. Okay, now we have this data in the person table. Now we have ID and the name. Now we don't have any index in the table. So first we have going to search the name. Okay, now we search the name. So if you want to see this kind of output, you have to enable statistics. So if you enable the statistics IO on, you will get this kind of an output. For that you have to type set statistics IO on. Okay, now if you see the table scan, it's a one scan, and the logical rate 72, which means 72 pages it's went to to to, to retrieve this output. Okay, now we are going to improve this performance for this query. Okay, also if you want to see that estimation plan also we can see. So this is the estimation plan. If you see, this is a table scan, which means that the condition is searched by row row. See, now I am searching Kevin. So what it will do, it will go row by row. It will search here whether Kevin is available in this row, and then go to next row, and the next. It's likewise, it will go like 20,000 rows we have in this table. So it will go till up to 20,000 row, and then it will give the output. That is called it as table scan. Okay, now we are going to improve this. So if I search this one, so this is the execution plan, it's table scan. If you see here, and then the logical rate is 72. I will make this one as a logical rate 72. It is before creating a cluster index. Now we'll see what is the logical rate after we create the index. Okay, now I am going to create cluster index in the column name. Okay, this is a syntax: create cluster index name, and then this is the table name, and this is the column name. Okay, I'm going to create this one. Okay, before that I will show you one thing. So now if you see, the name is not in a proper order, as I said, right? In that, as I said, when you're creating a cluster index, it affect the physical structure. Okay, so after, if you're creating this index, you could see this name will arrange it automatically in the alphabetical order. If you see, I'll show you. So this is something which start from side, if you see here, but after we create this one, now if I created the index, now I am going to check the same table again. See, now the name, everything is arranged in the alphabetical order. The ID also is got changed. Now everything is in alphabetical order. Okay, now if I do the same search again, if I search where name called Kevin again, you could see there. Now the logical reads only 3, as I said, right? It went only 3 pages to get this output. Before it went like 72 pages, now it went only 3 pages. We got the same output. Also, if you see the execution plan, now instead of table scan, now it's went to index seek, which means it will seek only that particular route. It won't go the complete, it won't do any complete scan. This is the advantage when you're creating an index in the table. So everything is arranged in a particular order. If you see here, okay, I'll give you one more example. What are the drawbacks when you're creating index? As I said, right, it will occupy more memory. Not only that, if you are doing a multiple insert in the table, it will affect the performance. But it will work best in when we are doing a select query. I mean, when you're data retrieval. But when you're inserting some data into that table, it will affect some performance. But not it's not like, you don't need to worry about that. But some performance will affect when you're creating an index in that table. I will show you how, because whenever if you are inserting something into the table, for assume that I have person in the table, I have index, so now I plan to insert some data into the table. Insert person values. So assume that I'm going to insert triple A. Insert into person values. Okay, if I inserted okay, I inserted triple A. Now if you search this one, it came here, because every time whenever if you insert something, it will go for into that particular index, I mean alphabetical order. It will insert there, it won't insert in the last rows. Okay, that is the reason I am saying it will affect the performance. I hope I am clear now. See, suppose if you are inserting something, if the person name starts with B, again, it will insert only at the position of that when it starts from the B. It won't start insert in the last one. Suppose if you don't have any index in the table, it always go in that last row, because it no need to search the particular index while inserting. It always insert in the last row, but when we have index, it has to maintain that order in the table. So that is the difference that which I want to share it with you all. I hope I am clear with the cluster index. In case if you have any doubts or any comments, please give me pop up in the bottom of the comments window. I will try to give an answer for that. In case if you don't subscribe to the channel, please subscribe. I will see you in the next video. I believe this session would be very useful in order to understand the cluster index concept. So next video I will cover what is non-cluster index, how we can use the non-cluster in the best way to search the query. Thank you all. Thanks for watching.